Hello, we're back. So the next section here is called the addition and subtraction of polynomials. So in the last section, I think we just kind of got familiar with all these, what is a polynomial, what are all the parts of it, terms, coefficients, degree of a term, degree of an entire polynomial, and then we saw how to evaluate a polynomial, substitute a value in and see what you get, and we saw a real life situation. So in this section, it's very short. Notice this is only a one-page section. I thought maybe I should make it longer, but then I thought, now I'm just kind of forcing more of the same examples. And I think if you can do these 4 examples here, then you can do anything in this section. So you're going to enjoy this. This is a nice short section, and all it is they're saying, it sounds like it's something different, they say, oh, we're going to learn how to add and subtract polynomials. But really all it is like if you look at example 1, part A, I think they have parentheses around the first polynomial, so they're saying, here's one polynomial, plus, okay, here's another one, so add them together. But really, you can just kind of take away the parentheses and think of it as one big sort of polynomial in combined like terms. So it's not really a big deal, it's just, remove parentheses, and then combine like terms, and that's really it. Like terms. The only thing you got to remember is you want to write it in descending order of powers. From largest, terms should be from largest degree to smallest degree. Largest degree to smallest. So keep that part in mind. But I mean, you probably already have that in mind from the last section. You're already in the habit probably. So I notice, I said remove parentheses, which it won't be a problem in these part A and part B, because you notice all that's in front of the parentheses, the second parentheses is a plus, and then the same thing in this next example that we'll see. So it won't be a problem to remove the parentheses. We just have to be careful. In example 2, they're subtracting. So you notice there's a subtraction sign here. That means we'll have to distribute it onto everybody in the second parentheses here, and then the same thing for the negative or the subtraction sign in the part B of that example. That's the only thing you got to be careful of. You remove parentheses. If you're adding 2 polynomials, it's no problem, just remove them. But if you're subtracting, you got to remember to distribute the subtraction sign onto the second polynomial. Yeah, distribute the subtraction, or you can think of it as a negative sign onto the second polynomial. And just remember, you have to put it on all terms. All of them. So be a little careful on that. Okay. Alright, but we'll start it with example 1. So as it says, you're just going to remove the parentheses, because the first parentheses on the left, they weren't really there for any reason. I think they just put them there just so you know. We're thinking of the one in the first parentheses as one polynomial, and the one in the second parentheses as another polynomial. But when you're combining them, it doesn't really matter. You can just kind of write all the terms next to each other and see what happens. Alright, so I got them all here. Should have left myself more room, sorry. But now, okay, we got these terms. There was nothing to distribute since I had a plus sign in front of the parentheses. And now it's just a matter of, kind of like in the last section, I'm going to look for the highest exponent. I think the highest exponent we have is a third power, and I see 1 in each of these polynomials here. And again, like the last one, all I'm going to do is, I'm going to keep the exponent the same, I'm just combining their coefficients. The first one's a 4, it's 4, and then a negative 1. 4 minus 1 is 3. So that'll be your first term. Let's see, and then the next highest power, I see some x squareds here. Negative x squared and a 7x squared. Okay, well it's like having a negative 1 plus 7. Negative 1 plus 7 is 6, and I'm not going to change the exponent on x. It stays the same when you're adding and subtracting these guys. Okay, so we've taken care of the third powers and the second powers. And now what else is there? We've got some regular x terms, the x with the 1 power. There's 2 of them here. I got a 5x and a 2x. 5x plus 2x makes 7x. And again, don't try to do 5x plus 2x is 7x squared. The x does not change. The power on x only changes if you're multiplying. Like if it was 5x times 2x, you're multiplying, or you're dividing, 5x divided by 2x. When you're adding and subtracting, only coefficients change, no exponents. And I think the only guys we've missed so far here are negative 1 and 5, the constant terms. So those guys will go last. We got a negative 5 plus, negative 1 plus 5, that'll be plus 4. So there it is. We've added two polynomials together and we got a new polynomial, which is kind of cute. That's really cute. But anyway, that's really how you do it. Just be careful if you're subtracting because you'll have to distribute the negative, but we don't have to worry about that since we're adding right now. So same thing with part B. I'm not really looking forward to adding all these fractions, but oh well. That's the problem for future me, not present me. So I'm just going to rewrite the first polynomial, the one that was in the first parentheses, but with no parentheses. And then the one that was in the second parentheses, I'm rewriting exactly the same because there was nothing to distribute into the parentheses. Nothing's going to change. Alright, now I'm looking around at this guy. I say, alright, who has the highest power right now? I've got 3/5 x to the 4th, 2/5 x to the 4th. Those guys can combine. And what you're really doing is you're adding their coefficients, right? The 3/5 and the 2/5. Thankfully, we got a little bit lucky on this one. They have the same denominator. 3/5 and 2/5, all you do is add the numerators. 3 plus 2 is 5. And the denominator stays the same. So that's kind of interesting. It just ends up being 5/5, but 5/5 is 1, right? And 1 times anything is that thing. So really it just becomes an x to the 4th. That one really simplified quite a bit. Alright, let's see. After x to the 4th, what's the next highest power? I think all you have left are x squareds and constants. So the constants should always go last. It must be the x squareds I want next. Although, sadly, those ones I have to find a common denominator. So I might, looking at those denominators, I have a 2 and a 4. The common denominator is going to be a 4. So I'm going to have to multiply the first fraction, or the first x squared, by 2 over 2. And I might write that out just to be safe. I'm going to write that guy out again. It was 1/2 x squared, now it's 2/4 x squared. And maybe just to be really safe, I'm going to write this guy next to him. Plus 1/4 x squared, the other guy. And now I'm able to add those guys together, and that'll be part of my final answer. Alright, that looks good. Just trying to keep everything color-coded here. So we got 2/4 x squared plus 1/4. All you do is add their numerators. 2 plus 1 is 3. And then the denominator stays the same. It's positive, so I'll keep it positive. And again, don't change the x squared. The x squared stays the same. You're not going to say x squared plus x squared is x to the 4th or something like that. Alright, then the last thing that we have not added yet are these constants. -2/3 and -1/6. And I have a feeling I'm going to have to find a common denominator again, because those guys do not have the same denominator. So, okay, the denominators are 3 and 6. Well, the common denominator between 3 and 6 would be 6. I'll have to multiply the first fraction by 2 over 2. Alright, then what'll he become? That'll become, let's see, a negative, and because it started as a negative. 2 times 2 is 4, 3 times 2 is 6, plus, and the other guy gets to stay the same. Oops, I mean minus, sorry. It had a negative sign. 1/6, okay. So let me combine those guys. -4/6 minus 1/6, that's -5/6. And there it is. Nothing really else to do. I just have to check, did I really combine all the like terms? Yeah, I think now that I look at what's left, there are no like terms left. They're all different types of terms, different exponents, or no exponent at all. And then, did I write them in descending order of powers? Yeah, the highest power, x to the 4th, comes first, then x squared, then the constant. So I did a great job. Just got to be careful when there's fractions, that's all. Alright, I think we're good with addition, right? It's just, pretty much it's combined like terms. Don't be afraid of the parentheses, they're not really there for any reason. They're just kind of, they look scary, but they're not really there for any reason. So for example 2, this is where you have to be a little bit more careful because you're subtracting. Oops, and since there's a negative in front of the second parentheses, you really have to distribute. So the second polynomial, the one that's in the parentheses on the right, all the signs will change, but the polynomial on the left will not change since there's nothing in front of its parentheses. So I'm just going to rewrite the first guy the same. 9z to the 6th plus z to the 5th minus 6z cubed minus 4z plus 5. That guy. And I should have given myself more room again, but oh well. What are you going to do? Alright, now I got to be careful. I'm going to distribute this negative sign. The negative on the z will make it a negative z. The negative on the 7z cubed will make it a negative 7z cubed. The negative on the negative z to the 6th, it's a negative, it'll be a positive z to the 6th. And the last term, it was a -4, but if I give it another negative, it'll become positive. There we go. Alright, so you just got to be a little bit careful, make sure all the signs and the polynomial on the right change since you're subtracting. And then I'll just be looking for like terms. What do we have? I see a lot of like terms, but I want to look for the largest exponent, because I want to make sure I write it in descending order of powers. I see that I have a z to the 6th twice here. A 9z to the 6th and a kind of like a 1z to the 6th. You can think of that guy as. So it's 9 plus 1, that's 10z to the 6th. That's how those guys will combine. So we've kind of, and it kind of helps me sometimes because there's so much going on. I cross them out when I add them. That way I don't worry about them. Then I can just kind of focus on what's left. So okay, after the 6th power, what's the next highest power? I see a z to the 5th here, huh? But he doesn't have any like terms, so I could just bring him down exactly as is. Oops, why'd I write a 6th power? I'm losing it over here. So 5th power, there he is. So he doesn't change. Now I'm going to cross him out because I've already taken care of that guy. I don't want to worry about him anymore. What else is there? The next highest power after 5, I think, is a 3rd power, huh? You have negative 6z cubed, negative 7z cubed. So it's going to be some kind of z cubed. I just have to add or subtract their coefficients. It's negative 6 minus 7. That's negative 13 z to the 3rd. Alright, so those two terms are taken care of. And of what's left, I see that there are two terms that have a z in it, like this guy, negative 4z and a negative z. Those will probably come next. And then the constant terms are last, the 5 and the 4. So I'm going to combine the z terms next. You have negative 4z minus z, that makes negative 5z. And then the constant terms you have 5 and 4 make 9. And I think I've taken care of everything, huh? Negative 4z and z, I combine those, 5 and 4. Alright, that means everything's taken care of. There it is in all its glory. It's a good looking polynomial right there. Alright, we're doing well. I think we're doing good. As long as you're careful, you should be fine with these. So let's look at this last one, and then you guys can move on to the next section. This might be the shortest video yet, huh? You say, oh, finally. Okay, so this one, again, the parentheses on the left aren't really there for any reason. I think they're just, like I said, trying to remind you that these are two separate polynomials that you're subtracting. I'm going to rewrite that the first polynomial on the left exactly the same as it was, but with no parentheses. But the polynomial in the right parentheses, everybody's sign's going to change because you're distributing this negative onto everybody. So it'll be a negative on the already negative 0.5 x to the 4th. That'll make it a positive 0.5 x to the 4th. And the next term is positive 1.2x, but the negative, when I distribute it, make it a negative 1.2x. And the very last term, you have a negative distributed onto another negative 0.5. Negative makes it positive 0.5. There we are. Now we have everything kind of laid bare for us. Now we just get to be crazy and say, alright, I'm going to combine everything. What's the highest power I see? I think it's some x to the 4th, huh? You got two of them here. And I have to combine their coefficients. So this one's kind of weird, but you're thinking of, this guy has a coefficient of 1, and this guy has a coefficient of 0.5. So that's really what you're adding here. 1 plus 0.5, that makes 1.5 x to the 4th. So it's kind of, in my mind, I was thinking about this. I don't see a coefficient of x to the 4th, but I know it's automatically a 1. 1 plus the other coefficient, 0.5, makes 1.5. Alright, now the x to the 4th terms are out of the way. Let me see what's next. Well, all that's really left are x terms and constants, and we know constants always come last. I'm going to focus on the x terms. You got a 0.4 and a negative 1.2x. Well, if you want, you can think of that, it's almost like 4 minus 12, you know? It'll be like negative 0.8x. Or you can go off and think about it off to, on the bottom. What's 1.2 minus 0.4? But keeping in mind your answer is going to be a negative because you're taking a small positive number and subtracting a larger negative number. Or, a small positive number subtract a larger number. So 1.2 minus 4, you're going to have to borrow, of course. Make this a 12. Okay, that's 0.8. There you go. So that must be 0.8, but again, it has to be a negative because the larger number was negative, the smaller number was positive. Alright, then our final terms here. We got a couple constants. What are they here? With all my writing, I almost forgot about the negative. So there's a negative 2.6 and a positive 0.5. It's kind of a similar situation that we were just in here. What the heck? Hello? Here we are. I have a 2.6, which is larger, and it's negative, and then a 0.5, which is smaller. I'm going to subtract those guys, but keep in mind my answer is going to be negative because the larger one was negative and the smaller one was positive. So 2.6 minus 5, that would be 2.1, huh? And it would be negative because, again, the larger number is negative. That's not the nicest looking answer I've ever seen, but it's not the worst looking answer I ever saw, right? But alright, hopefully that section made sense, and yeah, every homework problem is similar to one of those. I mean, The worst that can happen is you have decimals like this last example we had, or fractions like we had a couple back. But usually they're whole numbers or, I don't know, nice numbers. It's kind of rare where you get fractions or decimals, but I wanted to make sure to do those just so you know kind of how to go about it, and you don't look in your homework and say, hey, how come we did the easy ones on the video and then now we do the hard ones in the homework? That's a bunch of bullcrap. See, I was a student too once. I know how you guys think. Anyway, thanks for listening, and hopefully you're glad this was like the shortest video of all time. But I'll see you in the next video, and we'll have more fun. And the next one we'll be doing even more fun things, believe it or not. Believe it or not, we'll be multiplying polynomials. Yay! But okay, thanks for listening. I'll see you in the next one. Bye.